All right, so we've got shells. All right, so we have shells and we have all these common dot files that we're going to keep and build for all of our different machines. And we're maybe doing development on a Macintosh like me, and I'm uploading to a server that is running Linux at some remote location. And, the two are not the same. On one of them, my home directory is /user/pschlump, and on another one, it's /home/pschlump, and I have different passwords and different logins and all this different configuration. So how do I make it portable? Well, there's some real simple steps you can do. You can put some if statements in your configuration files, and you can look at what your host name is or what type of a system. Certainly, I do configurations based on host name some of the time. And you'll notice here I'm setting a variable that I'm not exporting called HN. I'm setting it to $, which takes the output from the host name command and puts it in that variable. And then I just use some if statements to check if I'm on a particular host. I happen to have servers peach and tomato, which are both fruits. And I will just check whether or not I'm on a peach or I'm on a tomato. And I will set the appropriate aliases, the appropriate configurations for that system. That's fairly simple. I also sometimes just check whether or not the current type of a system is a Linux system, because some things are Linux specific and other things are Macintosh specific, which the uname is Darwin, because it's the Darwin OS. So you can have ifs to make your stuff work across systems. That's far simpler than having entire separate files, or because most of the stuff is the same across all of them. In fact, I don't think I changed my vimrc file and different on any system, but it also has the capability of having ifs inside it as well. Usually this is what I do for my shell scripts. So bash rc and zshrc. Now, I also have set up some things with passwordless login. We talked about using SSH to connect to other systems. SSH also has the capability of connecting without a password. If I just log into a remote system, generally speaking, what happens is it prompts me for a password to log in. And this is not the most secure login, although SSH uses a much stronger authentication system than most other logins. A stronger authentication than that is using a thing called public-private keys and strong encryption to do the validation. And the nice thing about the strong encryption system is not only is it much better than a password because it never sends any kind of non-public information across the wire that could be intercepted, but it also doesn't require that I type in a password. So if I go and log into a particular system here, let's say that I log into my server. Let's see how this works. The 199 server has this. Okay, you'll notice that when I logged in, it didn't prompt me for a password at all. And I'd like to show you how to set that up. And there are some other advantages of using a passwordless system. Particularly, there are tools like rsync that allow you to copy entire directory trees and back them up. And rsync requires that you have already set up passwordless logins. There is a deployment system that is commonly used for large sets of computers called Ansible. And again, it requires the same thing as SSH without passwords. And once you've set this up, this means that you can access these computers. You want to copy a file, you just put in SCP and the information where you want to copy it. It doesn't prompt you for a password, and it just copies it. So it's really useful. It's fairly simple to set up. And let's talk about how it actually works. Okay. I've got SSH on a machine that I'm on, the calling end, and SSH on a destination. Now, the SSH on the calling end asks the destination, what do you want for your authentication to prove authenticity? And the destination says, the things that I accept for proof of attestation of who you are is public-private key pairs and password authentication. SSH can actually use other authentication systems instead of this, but let's say that that's what the default is that's configured, which is pretty normal. And then the sending says, I have proof of who I am because I have a key pair. And I can use my private key to take a message, and I can create a thing called a digital signature on that message, and I will send you the digital signature. And the destination says, oh, you wanted to do it that way. Okay, I've got this digitally signed piece of text. Now I will go and look at the public keys, and I will see if I have an appropriate public key for this. And with that public key, I can then verify your signature and prove that you have the private key without ever seeing the private key. So the combination allows you to log in, but all you've transmitted is this digital signature. And the digital signature in no way reveals your private key. And your public key is public. Anybody can see that. So it allows you to prove who you are, to provide attestation of your login without ever transmitting any private data, which is, in my worldview, rather clever. So if the public-private key pair fails, okay, you may have more than one public-private key pair, it'll successfully try each one. If it fails, then it says, no, you have to provide me with a password. And then you get the prompt for a username and password. So it works really well. And it assumes that you have SSH on the destination system and on your host system. So I've put in the commands there to install SSH on an Ubuntu system, Linux. On Red Hat, you use yum instead of apt-get. You have to look that up if you want to use it. On a Macintosh, SSH is already installed, so you don't have to install it. New versions of Windows also come with a version of SSH pre-installed. So this thing is around pretty commonly. But you have to have a key pair. Now, there are other ways of getting a key pair. This is the simplest. If you have SSH installed, you can just generate a key pair. So you say SSH key gen, and you provide it with some options. In particular, I'm generating an ED25519 key there. And long ago, they started out with public-private key encryption with RSA. But over time, RSA keys have gotten bigger and bigger for some mathematical reasons. These days, you probably want to generate a 4K key. That's 4,096 decimal digits in length. And that's pretty big. And the computation, the bigger it gets, the slower it is. However, there is this other thing called elliptic curves. And one of those elliptic curves is this ED25519 elliptic curve. And I've chosen that particular elliptic curve. The default elliptic curve is spec 256R1, often called P256. And that elliptic curve has come under some doubt because it appears that when the NSA created it, they may have created some sort of backdoor into it. So somebody else created an elliptic curve that is a famous cryptographer, and it is called this weird name of ED25519, and pretty much everybody uses it. This is the one that Google and Facebook and Twitter use for all of their stuff. And it has all the good advantages of elliptic curve, but it doesn't have this shadow over it. And it is sufficiently common these days that even the National Institute of Standards accepts this as a valid elliptic curve and has said that, yeah, you can use P255, but we recommend this other one. So this is the curve to use. Now, when you go and generate this curve, okay, it's going to prompt you for some stuff. I don't put in a passphrase, and that makes it easier to use, but it's less secure. If you put in a passphrase, then every time you use your key, it's going to prompt you for a password, and that kind of defeats the utility of a passwordless login. But, so when it prompts you for the passphrase, just hit enter, and you end up with some output that looks like this. Okay. And it has created this public-private key pair in your .ssh directory. Now, the important part is one of these is a private key. That's the ID underscore ED25519. And it's really important that you keep your private key private, because if you lose your private key, all of your authentication is lost. So don't lose that file. And if you're using that file for stuff that is secure, if you lose the file, you will never get to that secure stuff again. It is over. So don't lose the file and don't divulge the file. That's the key there. The public key is public. I mean, you can give it to people. You can ship it off to some other system. And in this particular case, if we do an ls of that directory, we'll see that I actually have RSA keys too, but there's my public-private keys that I just generated in that directory. And I also have this other file, authorized keys. Now, on a particular host that I have, let's go back to my Macintosh. Okay, so my connection is closed. And I've got a bunch of keys in here. What I've done is I have taken the key that I generated on the from system, okay, that's this guy, and I've sent it over to my destination system. The destination is the one that's going to receive the public key. And then I have appended that data to the bottom of my authorized key file on that system. So the combination of things that I have to do, okay, is, first of all, on the from system, I copied my public file. It's important you only copy the public one because remember, you keep the private one private, so it has to stay on your computer. But I copy the public one to the destination in some location, in this case /temp. Then I log into the destination, and since I don't have authentication set up, it's going to prompt me with a password this time. I log into my destination, all good. And when I get there, I have to have SSH installed on that destination, obviously, or I'm not going to be able to log in. And I make certain I have this SSH directory. Then I take that temporary file and I append it to my authorized keys. The append is my pipe to append. If the file doesn't exist, it'll create it. If it does exist, it doesn't overwrite it. It sticks the new stuff at the bottom, which is what I want. Now, SSH is pretty particular about security, so you've got to make certain that you have the permissions set correctly on both the file and the directory. And the next two commands do that. The first one says, only the owner can read and write this file. Nobody else can see it, which is kind of important because it has keys in it. And only the owner can read, write, and search in this .ssh directory. No one else can see it. And then I get rid of my file in the temporary directory. And when I am done with this, I now have this authorized key file in here that is the list of all the keys that can log into this system on this account. So now I turn around, I log out, and I immediately log back in. And guess what? At that moment in time when I've logged back in, it doesn't prompt me for a password again, as long as I have my private key file in the signature. And I get to use these other tools like rsync and Ansible and other things that rely on passwordless authentication. There's one more thing I want to talk about SSH, and it's a very powerful thing. It's called port forwarding. And I don't have any diagrams for you of port forwarding, but we'll talk about port forwarding. You're doing something like you have sitting in your office at UW a computer running a database that you want to use for tracking something. But you're working from home and you don't have direct access to the machine because there's a firewall that the university runs between you and your machine in your office. But you do have SSH login. So you can log into the university with SSH and you'd really like access to your database up there. You know that your database is running on port 5432 and you'd like to access it from home. So what you can do with SSH is create this tunnel or this SSH port forward. And the pieces of this are where you want this to be shown on your local system, in this case localhost, which is the machine I'm working on, what port you want to use on the local system, what the address is on the destination, and what port on the destination. And then your, in this case, pschlump at uwyo.edu, your login information to log into that destination's SSH server. And normally this port is blocked, so you can't just access it across the web. And you'll notice that also I've used an address here that is not necessarily public to the world. It's network address translated. But you log in and SSH happily sets up this tunnel now that allows you to connect to, on your local system, to port 6543. And instead it shows up on the remote machine as this other port, and the data will go back and forth through this tunnel. And since they've given you access to port 22, which is the default for SSH, everything gets run over port 22 as encrypted data, and you now have a tunnel into this remote system. It's kind of important at that moment to talk about Tootsie Pop security. I don't know if any of you are old enough to remember the little owl licking the Tootsie Pop, and it goes to get to the soft interior. But lots and lots of businesses work on what I call Tootsie Pop security, where, you know, if you get past the firewall, you have access to everything on the inside. And the inside is all soft and easy to access, and the outside is this hardened firewall around everything. Now, the problem with Tootsie Pop security is as soon as you can build a tunnel, you're on the inside. And when you're on the inside, there's no security. It's all just happiness and joy. And interestingly enough, I think the University of Wyoming falls in this criteria because we only have two-factor authentication when we're on the outside. But when we're on the inside of the firewall, it's just enough to just use a username and password. And you have to wonder how many different ways you can breach the firewall and set this up. I will note for you that I have found at least one printer at the University of Wyoming that has SSH login capabilities. So you could SSH into a printer, set up a tunnel like this, and be across the firewall and on the inside of the soft GUI security. So, you know, you got to be aware that these things exist both for the utility of using it and also because the best security is where you assume that there is no firewall and every system has to have strong authentication and strong security all the time. Now, if you're going to use a SSH tunnel on a regular basis, you probably want to set it up in your SSH config file. And I've given you a little example there of the kind of stuff you'd have to set up. But basically, it's the same thing as on the command line, but you have to name the things a little differently. And you stick it in the config file, and now, magically, when you log in every single time to this destination, it sets up a tunnel for you. And if you're going to do it on a one-time basis, I just put it on the command line. If it's going to be frequently, like I'm testing and I have my grading database on a computer in my office and I do it all the time, then I turn around and I configure it so that every time I log in, I get that tunnel and I can access it remotely.